Hello YouTube! Today I wanna tell you about my favorite mega number, and this number is 5,592,405. Yeah, I don't remember my favorite number, because actually it's not about the number, but about the sequence that produces this number. I haven't found this sequence in the encyclopedia of integer sequences, so I wanna share it with you on YouTube, and also I should probably add it to this encyclopedia because I find this sequence very interesting. Although I'm not a mathematician, I'm a software engineer, and about 8 years ago, when I just started to learn programming, I was making a computer game. And there was one place in this game where I accidentally got very chaotic behavior. But it wasn't random, I found out that it repeats after some time, but I didn't pay much attention to it. And just recently I looked at this my old game and thought, oh, this is cool, what if I take this chaotic part and turn it to something more mathematical to explore? And so here it is. Suppose we have a sequence of zeros, and then we take the first zero and set it to 1. Now we have sequence 1, 0, 0, 0. And then on each step, we do the following. If a digit have changed, we put a 1 after it. For example, here, the digit has not been changed. So we put 0 here, and 0 here. And actually, this is connected. So this is a previous to this number, and this hasn't changed. So we put 0 here. And now this changed, and this changed. So after this, we put 1 here, and after this, we put 1 here, and those are zeros. And after some number of steps, it will eventually return to all zeros. And then the whole process repeats. Okay, actually it was a difficult example. Let's look at the simplest case. And that simplest case is just one digit. We always start with all zeros, and then we take one of those zeros and turn it into a 1. But here it's only 1 0. So we turn it into 1, and then we see that this digit has changed. So the next one should be 1, but the next one is itself. So we put 1 here, and now it hasn't changed, so we put a 0 here, and then it turns to 1, and then 1, and then 0, and so on. So it repeats after 3 steps. If we take 2 zeros, we can notice that it repeats in 6 steps. If we take 3 digits, then it repeats in 15 steps. So here we have our sequence. 3, 6, 15, 12, and then 255, 30, 63, and so on. So first of all, each number in this sequence is divisible by 3, and also every element in this sequence is divisible by its position in the sequence. For example, the first one is 3, and 3 is divisible by 1, what a surprise! 6 is divisible by 2, 15 is divisible by 3, 12 is divisible by 4, and so on. And also, if we double the position, the number also doubles. For example, the first one is 3, the second one is 6, fourth is 12, and then 24, so it doubles every time. And if we take any other number, for example 5, it's 255, and if we double it, we get 510. I don't have a proof that every number should be divisible by 3 or that it doubles every time we double the index, but at least it's true for all the numbers I've checked. And if it's true, we should compute only the odd numbers, because even numbers are the same, just 2 times bigger. So let's just get rid of all even numbers. And now huge portion of those numbers are just powers of 4 minus 1. So for many of those numbers we get just ones if we convert them into binary. Let's mark those numbers in green. Also some numbers have a string of ones and zeros, followed by zeros, and then the same string of ones and zeros as before. Here we can see the same pattern. And also here, I marked such numbers in yellow. And also we have numbers like this. Here again we have a sequence of ones and zeros, and then ones, and then the first sequence but inversed. So here is 1 0 0, but here is 0 1 1. You can see the same pattern here and here. Let's mark those numbers in blue. By the way, you can notice that for some reason yellow numbers appear only in prime positions. So we've divided those numbers into 3 groups, but there is one more, and it has very special form of ones and zeros. So let's mark this number in red. And this is the number I've chosen for this video. So we've divided those numbers into 4 different types. I don't know if there are any other types exist, but I found something else interesting. If we take a green number and count how many ones it has, and then divide it by 2, we get some number, this. Or we can express it as logarithm of this number plus 1 base 4. Now, for every blue number, we divide it into 3 parts, those sequence of ones and zeros, then ones, and then the sequence inverted. We just count the amount of ones and zeros, except the inverted sequence. So here it's 1, 2, 3, 4, 5, 6, except the final part. So here we put 6. And here we also take this, except this 0 and everything that comes after this 0. And we do the same here. And here we got 20 and 18. For yellow numbers we also divide it into 3 parts and take everything except the final part. There is a sequence of ones and zeros, and then sequence of just zeros, and then the same sequence of 1 and zeros, which we don't take. And we count those numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we put 10 here and 12 here. And this special number we also can divide into 3 parts. A sequence of ones and zeros, and then a 0 in the middle, and then the same sequence again. And if we count everything except the last sequence, we get 12. So at first we got rid of every even number, and then we applied some rules that might seem very arbitrary, and we suddenly get this sequence, which is here. I hope this was interesting, and thank you for watching.